Lesson 4 is a review of all the lessons we've done prior. So we're going to look at number 1. It says Mrs. Kokina surveyed her students to find out their favorite activities outside of school. And then basically there's a chart and all the activities and how many students like those activities. We are supposed to write a ratio comparing the students whose favorite activity was skateboarding to the students whose favorite activity was shopping. So again, we want to read that statement really closely. They want a ratio comparing the students whose favorite activity was skateboarding. Compare that to, we know that's going to be our fraction line, the students whose favorite activity was shopping. So we look up at the chart. Right there we see an 8 is a skateboarding. 2, there's my fraction line. Shopping is a 4. If I reduce that, I could divide the top and bottom by 4. 4 goes into 8 twice. 4 goes into 4 once. I would want to keep that as 2 to 1 just because they are asking for a ratio, and a ratio is a comparison of two numbers. So we would just say 2 to 1. Question 2 says Monica has 3 red roses in a bouquet for every 5 yellow roses. The bouquet has 2 dozen red and yellow roses. How many are red roses? Use a ratio to solve the problem. So I just read the question, and step 1 is to make sure we discover the problem, and so we're going to retell it. We have a girl named Monica, and she has 3 red roses in her bouquet for every 5 yellow roses. So right there it's telling us the ratio. We do know that the whole bouquet has 2 dozen red and yellow roses combined. What we're wanting to find out is how many are red roses. We know this is a ratio problem. Right here is a big key word that it's going to be a ratio problem because the for every statement. So I'm on step 2. This is the I, which we identify the important information. We always want to underline the ratio statement. The ratio statement is right here. She has 3 red roses for every 5 yellow roses. So right there is our ratio statement. And we are going to go ahead and put the information now in the diagram. So in our ratio statement, we have a ratio directly given, 3 red for every 5 yellow. So that's going to go right here in our circle. And I'm not going to go any farther until I label the top and the bottom. So it says 3 red, 5 yellow. And then I'm going to go over here. I'm going to put the labels the same, red and yellow. And then the question we are being asked is how many red. We don't know the red, so let's go ahead and put our X right there. Don't know the red. The only other information we're given is we know there's 2 dozen red and yellow roses. So 2 dozen is actually 24. So we're going to change that 2 dozen to 24. 1 dozen is 12. So we basically are given that there's 24 total roses. So we can put the 24 here. That's the only place it is to put the 24. The only problem, it's not 24 yellow. It's 24 total. So we're forced here to go ahead and change this label. So it's going to change to a T, which means I have to go over here and I have to change this label to a total. And we just look at the original ratio. If I had 3 reds, I'm just going to draw that out, 3 red and 5 yellow. So 5 yellow. You can see that would be 8 total flowers. So we're going to change your part-to-part ratio of 3 to 5 to part to whole, which would be 3 to 8. Okay, now comes the easy part. Now we're ready to solve. We should be looking at estimating on these. So if I want to estimate, I know my numbers are getting bigger. So 8 is getting bigger to 24. So this number 3 better not still be a 3. So I know my estimate right here, it's going to be more than 3. Okay, but we know 3 compared to 8. This is less than half of 8. Exactly half of 8 is 4, and it's less than that. So half of 24 is 12. So we know our answer better be smaller than 12. So our answer when we calculate should be between 3 and 12. Now we can go ahead and grab a calculator if you want. Everybody knows hopefully that you can always multiply the diagonal numbers, which would be the 24 times 3 and divide by 8. And that would give us our missing number. Or this is a very easy mental math question. You should be able to see that the bottom is getting 3 times bigger. So therefore the top's going to get 3 times bigger. And my answer is going to be a 9. And you can see there's 9 red, and it does fit in between our estimates. And the last one is, does that make sense? If I had 24 roses, could 9 be red? Sure. That could make sense. And the last problem here, number 1, it says there are 28 employees at a local bank. Every morning, 5 out of 7 use Route A to drive to work. How many employees use Route A to drive to work? I don't have a lot of room here, so I'm going to have to be pretty tiny. So we know it's a ratio problem, number 1, because this little phrase right there, out of, that's a big key, that word, that's what we're doing a ratio. And so I'm going to go ahead and underline my ratio statement. Every morning, 5 out of 7 employees use Route A to drive to work. So in my circle, I'm going to go ahead and put a 5 to 7. I'm going to try to solve this without the circle, if that's okay with you. So 5 to 7 use Route A to drive to work. And before I put any other number over here, this would be on the left-hand side would be where my rectangles would go. I need to label it. What do 5 out of 7 employees do? They use Route A. So I'm going to put 5 uses Route A. And then the 7 would have to be the total, wouldn't it? So I put a T down there for total. So my labels over here, the top is going to be the amount that use Route A, and the bottom is going to be using total. Okay. And then the only other number they give us is there are 28 employees totally at the bank. Well, this is going to be a nice, easy, straightforward one because the 28 is going to go on the bottom where the other label of total goes. I am looking for Route A. I should have put that first. Sorry. That X should have been I'm looking for A. The X goes where the A is. Okay. I'm ready to solve. You can take a calculator and take 28 times 5, divide by 7 if you like. Or mental math just shows us that the bottom is getting 4 times bigger. The top is getting 4 times bigger. So the answer, 5 times 4, is 20. And we're going to see if that makes sense. Could 20 employees use Route A if there's 28 employees at the bank? Yeah, that does make sense. Okay, our next problem says Derek has a Chihuahua named Spike and a Great Dane named Daisy. He gives Spike 2 treats for every 5 treats he gives to Daisy. In April, he gave Daisy 60 treats. How many treats did Derek give to Spike in April? So our first rule is D, discover. We just read it. We need to discover the problem type. So we want to always retell our question. So I have 2 dogs. One, Derek's a Chihuahua, and they call him, Derek has a Chihuahua, and they call him Spike. He's got a Great Dane, and she's named Daisy. And Derek will give Spike 2 treats for every 5 treats he gives Daisy. And then in April, Daisy got 60 total treats. And what we're asked to find out is how many Spike got in April. So we know it's a ratio problem. The reason I know it's a ratio problem is because there's that key word right there, for every. So I've identified the type of problem, and now we are going to go to the I step. This is step 2, the identify the information. So we always want to underline the ratio statement. Well, the ratio statement is right here. He gives Spike 2 treats. For every 5 treats he gives Daisy. There's that key word. Helps us find our ratio statement. And then we're going to go ahead and we're going to put the important information in our diagram. So when I look at my ratio statement, the ratio is right there for us. 2 treats for every 5 treats. So that's given directly to us. So I'm just going to go ahead and write that right there. And I'm not going to go on until I label. So what does he do too? He gives Spike 2 treats. So Spike is going to get 2 treats. For every 5 treats, he gives Daisy. So Daisy gets the 5. So those are my labels. So over here has to be a Spike, and over here has to be the Daisy label. All right, now I'm going to look to see, what do I want to know? I want to know how many Spike gets in April. That's where my X goes. And then I'm going to just look to see what other information they give us. They said he gave Daisy 60 treats. This bottom here is Daisy, so that's pretty nice, straightforward question. Don't have to change any ratios, which is really nice. Okay, so now we're going to go ahead and estimate. Well, you can see that the bottom here goes from 5 to 60, so it's getting bigger. So this top better get bigger. So in other words, this top number here better be bigger than 2. And then we look at, let's compare this, top to bottom. So so when we compare top to bottom, it's when we look at 2 compared to 5, 2 is less than half of 5. Exactly half of 5 is 2.5. and we're only at 2. So I know this is less than half. And so I look over here and I have 60. Well, less than 60, half of 60 is 30. So I know my answer better be smaller than 30, better be bigger than 2. So now I can go ahead and multiply. You can use a calculator, so if you certainly want to take 60 times 2 and divide by 5, you can do it that way. Mental math, I know I can see on the bottom here I'm getting 12 times bigger. So that means the top's got to get 12 times bigger, which means the answer, 2 times 12, is a 24. So now the last one, the C is check, make sure it makes sense. How many treats did he give Spike in April? 24. Would that make sense? That's, small dog, Spike, got 24 treats. The big dog, Daisy, got 60. Yeah, that makes sense. Okay, in problem 2 here, it says Alicia had a large bag of holiday M&M candies that had 72 green candies. There are 8 red candies for every 12 green candies. How many red candies are in the bag? Okay, so I just read it. I'm on the discover part of this problem solving. And so I read it, and now I got to retell it. So we have the squirrel. She's got a really big bag of M&Ms, and in it has 72 green candies. And we also know when they describe the bag that there are 8 red for every 12 green candies. So they're giving us a ratio there. And the question wants me to find out how many red candies are in this bag. So now I'm on the second step, which is I for identify. Before I know it's got to be a ratio statement. Number 1, see this little key phrase here, for every. That's a key phrase that we're doing a ratio problem. And identify the information means I underline the ratio statement. So right there it says there are 8 red candies for every 12 green candies. So there's my ratio statement. I underlined it, and now I can go ahead and put the information in my chart. Right in the ratio statement, it says there are 8 red for every 12 green. So that's going to go right over here in the circle, and I'm going to label it. There are 8 red for 12 green. So I got it labeled, which means over here there's going to be red and there's going to be green for labels. Before I go on, I'm going to say, what do I need to know? I need to know red. That's where my big X goes. That's where my answer is going to be. And I look and try to fill in all the rest of the information. It says she has 72 green candies, and right here, it's very convenient. Green is my label. So I don't really have to change much on this question. With this now, if we wanted to estimate, we can see the bottom is getting bigger, so my top better get bigger, so it better be bigger than 8. And if I look at this, 8 is more than half of 12 this time. Half of 12 is exactly 6, and you're more than halfway. So I have to be more than halfway of 72. So I know, so I know my answer. If I think of what is exactly half of 72, that's 36. And I know I have to be more than 36, so I'm going to change my estimate here a little bit. So it better be bigger than 36, because exactly half of 72 is 36. I know it's bigger than that. Smaller than what, though? These numbers right here, 8 and 12, they're not the same. It goes small, big. So the number here, where the X is, has to be smaller than 72. It can't match. So I could say it's got to be 71 or less. The reason is it's going here, small, big, and right here it's going small and then big. Okay. So now you can grab your calculator if you like, and you can take 72 times 8 and divide by 12. Otherwise, I can see the bottom is getting 6 times bigger. 12 times 6 is 72. The top has to also get 6 times bigger, which means 6 times 8 is 48. So now I'm at that last step. Does that make sense? First of all, it definitely fits inside our estimate, so that's good to go. If I had 72 green candies, could there be 48 red? There are less red than green, then that's a really good sign, because it says in your ratio 8 red for every 12 green. So yeah, that's pretty good common sense answer. Okay, our final question says at Washington School they keep track of all the books students read. For every 9 7th graders in the school, 5 claim that Harry Potter is their favorite book. Washington School has 90 7th graders. How many 7th graders prefer Harry Potter? So I'm going to retell it. We have a school. and they are paying attention to how many books, the books that students read. And it says, so for every 9 7th graders in the school, so for every 9 people, 5 claim that Harry Potter is their favorite. And then they do say that Washington has 90 total 7th graders. And the question we have to find out is how many actually like or prefer Harry Potter. Okay, so that was the discover step. It is a ratio problem again, mostly because right here is that key phrase, for every. We know we're doing a ratio problem. So I'm going to go ahead and fill in my chart. Well, they don't have a chart for us, so I can make my own. It's not a problem. There'd be a rectangle on top here and a rectangle on the bottom here. All right. So now I'm going to underline my ratio statement in my problem. It says for every 9 7th graders in the school, 5 claim that Harry Potter is their favorite book. And I'm going to go ahead and put the information in my chart. I'm right in my ratio statement. It says for every 9 7th graders, 5 like Harry Potter. So we can keep it that way. We can go for every 9 7th graders, 5 like Harry Potter. So we have 9 students. So for 9 students, 5 like Harry Potter. Okay. So over here, the top would have to be how many students there are. And then the bottom would have to be talking about Harry Potter. Okay. So now we need to put, we're asked how many like Harry Potter right here. That's where X goes. We don't know that information. So we have to see if we do have this information here. How many students are there? Right there it says 90. There are 90 7th graders. So that's going to fit nicely in our chart. And then we're going to go ahead and we can go ahead and multiply across and divide with a calculator if you want. 5 times 90 and divide by 9. Otherwise, I can look and say, oh, top is getting 10 times bigger. The bottom needs to get 10 times bigger. So 5 times 10 is 50. So my answer is 50. I have to check that to see if it makes sense. I did not remember to estimate on this problem. So we should look over here, see how it gets big, small, and our answer on top, this is big, and then our answer is smaller. So that's a really good sign. So out of 90 students, could 50 like Harry Potter? Absolutely.